Many of you might have seen numbers like square root of 36, square root of 48, or 2 square root of 27 in your exams. Now when you put them in a calculator, some of them can be converted into whole numbers. However, others result in infinitely lengthy decimals. In this video, we will look at how to work with such numbers accurately. Hi, welcome to My Exam Revision. In this video, we will be discussing surds. This lesson is divided into 5 sections. In the first section, we will define what a surd is and identify the common errors students make when identifying them. In the second section, we will learn how to simplify surds. In the third section, we will look at how to add and subtract surds. In the fourth section, we will cover multiplication. In the fifth and final section, we will discuss division.
I've added timestamps in the timeline below, so if you'd like to skip ahead to a particular section, you can do that easily. I've also included detailed notes in the description. If you'd like to go through the steps more carefully in your own time, you can click the link and follow everything step by step.
Now, let's get started. Let us begin by defining what a surd actually is. If you calculate the square root of 2, your calculator will show 1.414213, and the decimal places will continue forever without repeating. This is an irrational number. When we write an irrational root in its exact form using the radical symbol, we call it a surd. Therefore, a surd is the root of a number that cannot be simplified to a whole number or a fraction. Now, let us look at a common mistake. Is square root of 36 a surd? The answer is no, because 6 times 6 equals 36. The value of square root of 36 is exactly 6. Since 6 is an integer, square root of 36 is not a surd. In exams, always check if the number under the root is a perfect square before treating it as a surd. Using surds is important because it preserves accuracy. If you round square root of 2 to 1.41 early in a multi-step geometry or algebra problem, that rounding error will carry through to your final answer. Keeping the value as square root of 2 ensures your calculations remain mathematically exact. Next, we will look at how to simplify surds. To do this, we will follow a simple 3-step method. Let us work through our first example. Simplify square root of 48. Our first step is to write the number as a product of its prime numbers. To do this, we break 48 down. 48 can be written as 8 times 6. Now, 8 can be written as 4 times 2 and 6 can be written as 2 times 3. And finally, 4 can be written as 2 times 2. If we put all of these prime numbers together, 48 can be written as 2 times 2 times 2 times 2 times 3. Let us write this back under the square root symbol. Square root of 2 times 2 times 2 times 2 times 3. Our second step is to look for pairs. A key rule of square roots is that any number that appears inside the square root twice can move outside the root and become a single number. Inside our square root, we have 2 pairs of the number 2. We can move each pair outside of the square root and each pair becomes a single 2 on the outside. This leaves us with 2 times 2 square root of 3. Our third and final step is to multiply the numbers on the outside together. So our fully simplified answer is 4 square root of 3. Let us look at a second example. Simplify 2 square root of 27. Here we have a coefficient of 2 outside the root. Just like before, we will focus on simplifying the surd part first. Let us break down 27 into its prime numbers. 27 can be written as 3 times 9. Now 9 can be written as 3 times 3. So the prime factorization of 27 is 3 times 3 times 3. Let us put this under the root. Square root of 3 times 3 times 3. Now we look for pairs. We have one pair of 3's inside the square root. We move this pair outside where it becomes a single 3, leaving the remaining 3 inside the root. 3 square root of 3. Finally, we multiply this simplified surd by the original coefficient of 2 that was already sitting outside. So 2 times 3 square root of 3 equals 6 square root of 3. Thus, the fully simplified form of 2 square root of 27 is 6 square root of 3. This completes the first 2 sections of our video. You should now understand what a surd is and how to simplify one. Before we move to the next section, I want to quickly mention something that will help you practice this topic properly. On my website, My Exam Revision, I have created a full worksheet for each topic. It starts with basic foundation questions, then moves on to harder multi-step problems, and finally proper past paper exam style questions, all with step-by-step solutions. I've also built an AI version of myself based on my 14 years of teaching experience in GCSE Maths, A-level Maths, and further Maths. You can check the step-by-step solutions, and if you get stuck, you can simply take a photo and upload your working. It will analyze each step, highlight where you went wrong, and even if your final answer is correct, it will still check your method thoroughly. If you're serious about improving your grades, I highly recommend trying it. The link is in the description. Now let us return to the next section. We will now discuss how to add and subtract surds. The rule for addition and subtraction is similar to the rule for combining like terms in algebra. In algebra, you can add 2x plus 3x to get 5x. But you cannot combine 2x plus 3y because the variables are different. 2x plus 3y cannot be simplified. Similarly, you can only add or subtract surds if the numbers under the root symbols are identical. We call these like surds. Let us look at this problem. Simplify square root of 12 plus square root of 27. At first, we cannot add these because 12 and 27 are different numbers. However, we can simplify both terms first. First, let us simplify square root of 12. The prime numbers for 12 are 2 times 2 times 3. Since we have a pair of 2's, we bring them out as a single 2, giving us square root of 12 equals 2 square root of 3. Next, let us simplify square root of 27. As we saw earlier, its prime factorization is 3 times 3 times 3. Bringing out the pair of 3's gives us square root of 27 equals 3 square root of 3. Now we rewrite our original addition problem using these simplified terms. 2 square root of 3 plus 3 square root of 3. Because both terms now contain square root of 3, they are like surds. We add the coefficients together just as we would in algebra. Our final simplified answer is 5 square root of 3. Now, let us try a more difficult exam-style example that combines addition, subtraction, and outside coefficients. Simplify 3 square root of 20 minus square root of 45 plus square root of 72. Just like before, we cannot combine these yet. We must simplify each of the three terms individually using our prime factorization method. Let us start with our first term, 3 square root of 20. We break down 20. 20 can be written as 4 times 5. 4 can be written as 2 times 2. So the prime factorization of 20 is 2 times 2 times 5. Under the root, this is square root of 2 times 2 times 5. We have a pair of 2's. We move this pair outside the root to get 2 square root of 5. Now we multiply this by the original coefficient of 3 sitting outside. 3 times 2 square root of 5, which equals 6 square root of 5. Next, let us simplify our second term, square root of 45. We break down 45. 45 can be written as 9 times 5. 9 can be written as 3 times 3. So the prime factorization of 45 is 3 times 3 times 5. Under the root, this is square root of 3 times 3 times 5. We have a pair of 3's which we move outside to get 3 square root of 5. Now let us simplify our third term, square root of 72. We break down 72. 72 can be written as 8 times 9. Now 8 can be written as 2 times 2 times 2 and 9 can be written as 3 times 3. Putting all of these together, the prime factorization of 72 is 2 times 2 times 2 times 3 times 3. Under the root, this is square root of 2 times 2 times 2 times 3 times 3. Now we look for pairs. We have a pair of 2's and a pair of 3's. We move both of these pairs outside, leaving a single 2 inside the root. 2 times 3 square root of 2, which simplifies to 6 square root of 2. Now we rewrite the entire original problem using our three simplified terms. 6 square root of 5 minus 3 square root of 5 plus 6 square root of 2. Here is the important part you must watch out for in exams. We can only add or subtract terms if they are like surds. The first two terms, 6 square root of 5 and 3 square root of 5, are like surds because they both contain square root of 5. We can subtract these. 6 square root of 5 minus 3 square root of 5 equals 3 square root of 5. However, our third term is 6 square root of 2. Since square root of 2 is not the same as square root of 5, we cannot combine it with the others. It must stay separate. So our final fully simplified answer is 3 square root of 5 plus 6 square root of 2. Now we will look at multiplication. When we multiply surds that have coefficients outside the root symbols, we use a very useful general rule. A square root of b times c square root of d equals a times c square root of b times d. This rule breaks down into two clear steps. Multiply the coefficients outside the root symbols together, a times c. Multiply the numbers inside the root symbols together, b times d. Let us apply this to an example. Calculate 3 square root of 2 times 4 square root of 5. First, we multiply the coefficients outside the roots. 3 times 4 equals 12. Second, we multiply the numbers under the roots. Square root of 2 times square root of 5, which equals square root of 10. Finally, we combine these two results together to get our answer, 12 square root of 10. Since 10 has no square factors other than 1, this surd cannot be simplified further. There is also a special case you must remember for exams. What happens when we multiply a surd by itself? For example, let us calculate square root of 5 times square root of 5. If we apply our multiplication rule, we combine them under a single root, square root of 5 times 5, which equals square root of 25. Since 25 is a perfect square, this simplifies exactly to 5. As a general rule, any square root multiplied by itself simplifies to the number inside the root. For any positive number a, the square root of a times the square root of a is always equal to a. In our final section, we will discuss how to divide surds. The division rule is the opposite of our multiplication rule. Square root of a divided by square root of b equals the square root of a divided by b. This rule allows us to combine two separate roots into a single division under one root. Let us look at a basic example. Calculate square root of 50 divided by square root of 2. Using our rule, we combine these values under a single root symbol, square root of 50 divided by 2. Next, we divide 50 by 2, which gives us 25. Since 25 is a perfect square, we can evaluate this exactly to 5. Now let us look at a more complex example that includes coefficients. Calculate 10 square root of 18 divided by 2 square root of 2. To solve this, we divide the coefficients outside the roots first and then divide the terms inside the roots. First, divide the outside coefficients. 10 divided by 2 equals 5. Second, divide the inside terms. Square root of 18 divided by square root of 2. We combine them under a single root to get the square root of 9. The square root of 9 simplifies to the integer 3. Finally, we multiply the simplified coefficient by the simplified root value. 5 times 3 equals 15. Our final answer is 15. To summarize what we have covered today, a surd is an irrational root that cannot be simplified to a whole number or fraction. To simplify a surd, write down its prime factors and move pairs outside the root as single numbers. To add or subtract surds, simplify them first so that you are working with identical root terms. For multiplication and division, calculate the outside coefficients and the inside root terms separately. In our next video, we will build on these concepts and talk about the rationalization of surds. This is one of the most important topics in this whole chapter as it regularly comes up in the final highest marking questions of the exam, so you definitely do not want to miss it. I hope you enjoyed this video. If you did, please give it a like and subscribe to our channel. We will be bringing out more educational content like this, so make sure to follow the channel. Also, don't forget to try the questions on the worksheet linked in the description. Thank you for watching.